So, am I audible? Hello? Hello, Gokul or Sharmila, are you able to hear me? So, are you guys able to hear me?
Yes, sir.
Okay. So, what about others, Sharmila, Gokul?
One
Anyone
doubt,
can hear?
sir.
Ah, yes, Sutar?
Uh, Sir, today there are actually two sessions for network theory.
Yes,
One
yes.
session is from 6 to 8 p.m.
Yes, yes.
and another session is 7 p.m. to 9 p.m.
Yeah,
So today, whether we should attend 6 to 8 or 7 to 8, because it is overlapping, right?
yeah, yeah.
6 to 8 and
See,
7 to 8. What to do?
there's one 6 to 8 and one 7 to 9. So, I'm the teaching assistant who will conduct the doubt clearing and problem solving session from 6 to 8. There's another teaching assistant who will clear the doubts between 7 to 9. So if you join in this session, 6 to 8 session, and your doubts are cleared, there's no need to join in the session of 7 to 9. These sessions also are not compulsory for anyone to attend. They're just that you have some doubts, you want to learn further about the subject. So these sessions are arranged for that purpose.
So you are saying that people who are comfortable in 6 to 8 can just attend that session,
Yes.
and the people who are joining later, like 7, they are comfortable, they can join in that session, right?
Yeah, yeah, yeah. Yeah. So Gokul, my
Okay.
voice is not audible over time.
Voice is clearly audible, sir.
Okay. No, Google sent something. Voice is not audible. We'll rejoin again maybe. And okay, so okay, so Malot Mahesh Nayak, okay. So shall I begin teaching? You guys ready, right?
Yeah, yes, sir. Uh,
Oh,
if you want, you can wait for some more people. Otherwise, you can start the class
yeah, yeah.
session.
Understood.
Sir, sir, I actually have another doubt.
Huh,
The problems in the assignment are little bit on the tougher side. So how to?
tougher side. uh,
Yeah, yeah. So that's why I'm very confused. I think we should attend. Today
oh,
you have problem solving also, right?
yes,
The
yes.
practice pro.
So initially I will teach some theory. I will solve some example
Yes,
sums and
yes, sir.
yeah. So hopefully, while I'm doing the sums and solving it, your doubts will get cleared. In case there's,
Mm-hmm,
and so while I'm teaching the problems, also you can stop me and ask me if you have any doubt. And further, in case
mm-hmm.
you still have some doubts, then you can ask me what are your doubts. Okay.
Okay,
So
sir.
this are
Yes,
2 hour
sir. Yes, sir.
sessions. So there's ample amount of time. So you don't need to worry
Mm-hmm.
that your doubt will not be cleared. Okay.
Okay. Yes, sir. Yes, sir. Thank you.
Uh, Okay, so only few people have joined, so I think I will start. So is my screen visible?
You haven't shared it. Ah,
Okay,
which session?
so now the screen is visible, right?
Yes, sir, visible.
Okay, okay, fine, fine. Now this it's all also visible.
Yeah, visible. Problem solving session.
Fine. So, अच्छा. So today we'll have the first session for problem solving and
Mm,
doubt clearing for this network analysis course, which has been running for some weeks. And this course
mhm.
was being taught by Professor Tapas Bhattacharya from IIT Kharagpur. He's a retired professor, and now I'll be conducting the session. So I'm Calvin Paul Joseph. I'm a first year PhD student from IIT Kharagpur. Okay, so I will be the TA, and these sessions will be running like once a week. Every week on Monday between 6 to 8, I will be conducting these sessions. So you whatever, so I will be doing some demo problems I'll be solving, and I'll be showcasing that. So that will be so that you guys can clear your doubts. And in case you have further doubts and further problems and further questions regarding the theory or anything else, then you can ask me that doubt as well. Okay. So this
Yes,
is
sir.
there for you guys. And yeah. So we will start with concept of electrical networks like that. So you guys are all able to unmute and everything, right? So,
Yeah, yes, sir.
Susmitar, what is full form of KVL?
Uh, some more full form, Kirchhoff voltage law.
Uh, and Gokul, what is the full form of KCL?
Kirchhoff's current law.
Okay, okay, fine. So now it is clearly audible and everything, right? For you guys?
Yes, sir.
Okay. So now we'll begin. So we in this network analysis, the main concept is to be using KVL equations and KCL equations. So
Mhm.
so when do we apply KVL? When there is a mesh in the circuit. Okay, when there is a mesh, we apply KVL, and for nodal analysis, we use KCL equations. So now let us consider they have given some steps on how to solve. So let us we can solve the circuit by two methods. Either we use mesh analysis or we use nodal analysis. So we will start with some steps to follow to solve network analysis by mesh analysis. Okay, so this is one demo circuit. Okay, this is one demo electrical circuit where there are some batteries as well as there are some resistors. So this is an electrical network. It is a closed electrical network where there is a path for the current to flow. Okay, and also one more thing to keep in mind: it is a passive electrical network. Since it just consists of some independent sources like these batteries, as well as it only consists of some passive elements like resistors and all. Now, in case there was like some transistors or some MOSFETs or something else, then it will become a non-linear, as well as it could also become uh what do you say active network. Okay, right now this is just a passive network. So okay, now so okay, so here there are three meshes are there possible. So the mesh is the smallest closed path. Okay, so we have one closed path over here, we have another closed path over here, and we have a third closed path over here. Okay, so in each path we assign a current, like we assign the current flowing in this mesh to be I1, the current flowing in this mesh to be I2. Are you guys able to see my pointer?
Yes, sir. Yes, sir.
Okay. As well as the current flowing in this part to be I3. Okay. So what we have done is we have assigned unknown, these are unknown. We have assigned some mesh currents I1, I2, I3, and n is the number of meshes. There are three meshes, so we have assigned three set of unknown mesh currents. Okay. Now we will form n number of independent KVL equations in those meshes. So now we will apply KVL for this mesh 1. Okay. Then we will apply KVL for this mesh 2. Then further we will apply KVL for this mesh 3. Huh? Now, but just in case there was some sort of current source, let me just hold on. So, in case there was this circuit, okay. Now, just just hold on a minute. I'll just come in a minute. Huh? So, sorry for the delay. I got to bring my phone back. So, just suppose over here, okay, if there was a current source, okay, let us consider some current source, independent current source. Huh? If there was such a current source in this circuit, then we will directly assign I3 to be equal to 3 ampere. Okay. So there's this current source in this mesh. In this mesh, there is a current source at the external part of the circuit. And so we can directly assign the current flowing to be 3 ampere. And one more thing to notice, in this mesh, now you can no longer can now you cannot apply KVL properly. Because the problem is we can see we have the current is flowing through this resistor, so there will be some voltage drop. There will be current is flowing through this resistor, there will be some voltage drop. That depends on the current flowing through the path. Okay. Similarly, the voltage across the battery is fixed, so we know the voltage drop across that. Similarly, when this current flows to the resistor R6, there will be some voltage drop. But we do not know what is the voltage drop across this current source. That is unknown. That we cannot find out. So so that's why we and what our goal in this mesh analysis is, we just want to find the current through the mesh, and that is directly found through this. So with that, directly we can write this current I3 to be equal to 3 ampere. Okay. So any doubts till now?
Yeah.
Anyone has any doubts or anything, you can ask, or I'll proceed. Okay. So that's the thing. That's why they have written, if there are current sources are present in the outer meshes, those currents are already known. Okay. And so we do not need to write KVL equations for those meshes. Huh? So this will simplify our problem, and we can solve the circuit faster. Okay. Now, uh, now since there's no current source present over here, we will have to apply KVL for this mesh, KVL for this mesh, and KVL for this mesh. So how many? So we will get how many equations? We will get three sets of equations. One equation for mesh one, another equation mesh two, another equation of mesh three, and we will we will know the battery voltage E1 and E2. We will similarly know the value of the resistors. So the only unknowns are this current I1, current I2, and the current I3. These are the three unknowns. So we have three equations and three unknowns. So hence we'll be able to find the value of the current in each of the meshes. Okay. So now we will try to write the KVL equations for the meshes. So let us get rid of this independent current source. Okay. So now we will write the KVL equation for mesh 1. Mesh 1 is this.
Sir, I have some doubt in the sign convention,
Okay. Yes,
the
yes.
plus and minus. Yeah.
Ah, okay. So while doing the example, we'll try to clarify your doubt. Okay. So we will start at this point. Okay. We will let us start at this point. Okay. We are first doing the KVL for this mesh, and I will start at this point. Okay. So now there's a resistor R1 and there's current I1. The current I1 is flowing in this direction. Okay. The current I1 is flowing in this direction. So when we write KVL for the equation, this will be the plus sign, this will be the minus sign. Huh? So we are going in this direction. Huh? We are going in this direction. So it will be minus of I1 into R1. Okay, so the voltage drop across this resistor is I1 R1, and since we are going from the positive to the negative, it will be minus. Okay. Next, we will find the voltage drop across the resistor R2. So there is one current is flowing through the resistor R2. Okay, we will write that to be IR2 is the current flowing through the resistor R2. So this current IR2 is actually I1, that is the current flowing in this direction, I1. Okay, I1 current minus the current I3, because I3 is flowing like this. I3 is flowing in this direction, I1 is flowing in this direction. So this current IR2 is equal to actually I1 minus I3. Okay. Now, when we will find the voltage drop across this resistor, we'll take this to be plus, this to be minus. So it will be equal to minus of IR2 into R2. Okay. Then now we have traveled from here. We have come here. We have come here. Now we have to find this part. So now for a battery, now we are going from this point to this point. We are going from the positive terminal to the negative terminal. Okay. So that's why we will write it as minus of E1. Okay. Then similarly, we have to find the drop across this resistor R3. Okay. So the current, so the resistor R3, and let us see the current is in this direction. So because the current is in this direction, it is I1 minus of I2. Okay, so IR3 is actually equal to I1 1 minus of I2. Okay, so that's why the voltage drop over here is minus of IR3 into R3, which is equal to 0. Hmm? Then we will further substitute the values of IR2 and IR3. We will get minus of I1 R1 minus I1 minus I3 into R2 minus E1 minus IR3. Okay, this is minus of I1 minus I2 into R3, which is equal to 0. Okay. So anyone has any doubt till this point?
No.
Okay, no one has any doubt. Okay, that is good. Great. So no doubts still here. So it is written like this. Then we will just write. We can further simplify. Okay, how will we simplify is we will multiply throughout by negative sign. Okay, let us just write in simple terms. It will be minus I1. We take I1 common, so it will be R1 plus this here R2 comes, and from here R3 comes. So it will be minus I1 into R1 plus R2 plus R3 plus I3 into R2 plus I2 into R3 minus E of 1. This is equal to 0. Okay. So anyone has any doubts in this simplification?
No, sir.
Okay. So this is how we have written the KVL equation for this mesh 1. All right. Hmm. Yeah. Now we will write the KVL equations for mesh 2. See. Now we have to write KVL equation for the mesh 2. So one thing to keep in mind is for a voltage source, okay? Like someone wanted to know what is the convention. When we are going from the negative polarity to the positive polarity, then we will consider it to have positive polarity. Okay, but suppose we are going from here, we are going in, suppose we are going in this direction, then from here to here, it's going from positive to negative, then we will put the sign to be negative. Okay. Now, for a for a resistor, okay, suppose let us consider this resistor R5. The current flowing through it is I2. Okay, this is the current which is flowing, that is I2. Okay, so in the direction of the like from here, here like see we can say the current is flowing from here to here. Okay, so this part will be positive and this part will be negative. So the so while we are writing KVL from here to here, the polarity will be equal to minus I2 into R5. Okay. Any doubts in this one? This is quite confusing actually. Any doubts here?
No, sir.
Ah, that's good. So whenever like what I use when I do this mesh analysis is I will from where I'm positive to negative from like suppose it I'm doing for this resistor R6. Okay, the current is flowing in this direction. The current is like if I am traversing the circuit in the direction in which the current is flowing, then it will the drop will be negative. The sign will be negative. But in case the current was, but in case I'm writing KVL like this, okay, in case I'm writing KVL like this, I'm going in this direction, I'm going, then it will be I3 into R6 because that time the current is flowing in the opposite direction. Then I will write the polarity to be positive. Okay. Okay. So I will continue. Now I will write KVL for this mesh 2. Okay. So KVL for mesh 2, I will start from here. So I'm going from here to here. So minus I2 into R5. Now I want to find, now I have to go find a voltage drop across the resistor R3 and I am going in this direction. Okay. I am going in this direction. So the current flowing in R3 in this direction, that is in this upward direction, is equal to I2 minus I1. So the drop across this resistor R3, it will be equal to minus of R3 into I2 minus I1. Okay. Then I am going from here to here, minus to positive. So it will be positive E1. Okay. And for resistor R4, current is flowing in this direction, I2, and I3 is flowing in this direction. So it will be minus of R4 into I2 minus I3, which is equal to 0. So any doubts till this point?
No, sir. Clear.
Okay. So now we can further simplify. We will take minus I2 to be common. So it will be R3 plus R5 plus R4 from here. So plus R4. Then minus and minus, they become plus. So it will be plus of I1 into R3. Then minus and minus will become plus of I3 into R4 plus E1 is equal to 0. Okay. So this is the KVL for mesh 2. KVL for mesh 2. Now let us consider KVL for mesh 3. We will write KVL now for mesh 3. And in this time I will go in the anti-clockwise direction. Till now I've been always going the clockwise direction while writing KVL. Now let us try to go in the anti-clockwise direction. Okay, that is I am going to start from here. From here I will start writing KVL equations and I will come back and come off over here in this way. Okay, like this. So now from this point to this point, okay, there's a resistor. So the drop across the resistor will be equal to the current through the resistor into the value of the resistor. Now when I'm going from here to here, it is in the opposite direction of the current. That's why I will write it as I. Okay. So actually, this meeting is for only like this Zoom session is only for 40 minutes. So after this meeting Zoom session finishes, I will again restart the meeting. So that time you will need to again rejoin. Okay. So after some 10 minutes or something, this meeting will conclude. Then I will again start the meeting and again you guys have to rejoin. Okay. Yeah. So now it is the drop is I3 into R6. That is I3 into R6. As well as it is going from negative to positive across the battery. So it will become positive E2. Then it is going like this in this direction. So the current in this direction will be I1 minus I3. Okay, the current in this direction, it is equal to I1 minus I3. So that will be minus of R3, no R2 into I1 minus I3. Okay. Now why negative sign has come? Because I've considered the current to be flowing in the direction which I am going in. Okay, I've considered the current to be in the direction in which I am proceeding. But for this case, I'm proceeding in this direction, but the current flows in the opposite direction. That is why positive sign came. But in this case, I am proceeding in this direction. I've considered the current flow through the resistor to be also in this direction. That's why the sign should be negative. Okay. Similarly,
Sir, the I3 R6, that's
uh,
how it's positive once again.
yes. Okay. So I am going from this direction to this direction. Okay. I'm going from the right of R6 to the left of R6. And the current I3 is going in the opposite direction. So because the current flows in the opposite direction, that's why I get a positive sign. So is that clear?
Okay.
Hmm. But for this R2, I'm considering the current to be flowing from left to right. And when I'm writing KVL also, I am also proceeding from left to right. That time it will come negative. That time the sign will come negative. So that time the sign will be minus R2 into the current which is flowing from left to right. That is I1 current minus I3 current. So that's why I'm getting like this.
I1 minus I3.
Yeah.
It should be I3 minus I1, right?
No, no, no. See, current I1 is flowing in this direction. Current I3 is flowing in this direction. And I'm considering the
Yes,
current
sir.
direction to be like this. So the current direction is like this. It is equal to I1 minus I3, which is opposing. Okay.
Okay.
Hmm. Yeah. So similarly, for the resistor R4, I will consider current to be flowing in this direction. So it will be the current I2 minus the current I3. So the drop will be equal to minus R4 into I2 minus I3, which is equal to 0. Yeah. So effectively, I will write it, the equation to be I3, okay, into this R6 plus minus of minus, it becomes plus. So it will be R6 plus R2, and this minus also, so it becomes positive. So plus R4, okay, minus of I1 into R2 minus of I2 into R4 plus E2 is equal to 0. Okay. So thus we have written the equations, the KVL equations for all the meshes. Okay. So this is the equation for, this is the first equation. Okay. And this is the second equation. And this is the third equation. So E1, E2, value of resistors, all that are known to us. So the only unknowns are I1, I2, I3. So there are three unknowns and there are three equations, and hence we can find the solution, and hence we can compute, we can determine the value of I1, I2, I3. Okay. All right. So they have also shown how we have to get the values of how we write the KVL equations and how they have found it. Okay. Yes. So, so we will begin with this question. Till then, anyone has any other doubt or any other question which they want to ask? Anything else?
No, sir.
No. Okay. So, proceed. Okay. Good. Mm. So we will consider this circuit. Hmm? No, 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 like this circuit because that is nodal analysis. This is mesh analysis. We are planning to do. There's this circuit. Yeah. Okay, we'll end this meeting and I'll start a new meeting. Okay, so you guys join the time. Okay, I'll end this meeting and we'll start a new meeting.
Okay.
Hmm. So are you guys able to see my screen?
Yes, sir. Yes, sir.
Okay. So now we will proceed in solving this equation. Okay. Hmm. So wait for some people are joining. Draw completely. Okay. Off. So now in this circuit, we will consider there are actually four meshes are possible. Four meshes are there. Huh? So we will, so because there are four meshes, we'll have to draw four sets of current. So in this mesh, we will consider it to be the current flowing to be like this. This is I1. Similarly, for this mesh, the current is flowing like this, which is I2. Similarly, for this mesh, the current flowing is like this. This is I3. And similarly, over here, the current is I4. Okay. So now there are four meshes, and so we have written four. We have assigned four unknown current variables: I1, I2, I3, I4, one in each mesh. Okay. Now, if we consider in this mesh over here, there is this current I3, and there's this independent current source of 2 ampere. So that what does it mean? We can directly write I3 to be equal to 2 ampere. So anyone has any doubt or problem in this part?
No, sir.
No, right? Okay.
Mm-hmm.
Similarly, here we have a current. Okay, someone is not John. Okay. So now we have current flowing like this. There's another independent current source over here. Okay. So now what we will do for this current source, there's this current I2 which is flowing like this, and I1 is in the opposite direction. So directly we can write it as I2 minus I1 is equal to 3. Okay, this E we can ignore. I2 minus I1 is equal to 3. So this is the relation between the current I2 and I1, and that is because of this current source. Now, what we will do is we have to write. So we have found two equations already. We have found two equations, but there are four unknowns. So we have to find two more equations. So as I said, we cannot write KVL for this mesh. because there's this independent current source and we don't know what is the voltage across this current source. So we will apply KVL across this entire mesh, across this entire circuit. Okay. So when we will write, so can you guys understand? I'm going to write KVL from here. I will traverse like this. I will go like this. I'll go through this voltage source and I'll come back and I'll come back to this part. So I'll apply KVL for this, for the lower section of the circuit. Okay. So I will apply KVL for the lower part of the circuit. So that will be equal to, now I'm starting from here to here. Okay, as I said, from negative to positive. So it will come 20. It will come positive 20. Similarly, the current flowing through this resistor is in this direction. It is in this direction. And I'm also traversing the same direction. I'm also going in the same direction. That will come in negative sign. Negative 20 into I2. Okay. Similarly, for this voltage source, I'm going from negative to positive. So it will be positive. So it will come plus 10. Now, across this resistor, the current flowing in this direction is equal to I1 minus I4. Okay, this I1 minus I4. So that I will write it as minus 5 into I1 minus I4, which is equal to 0. So any doubts till here? Any questions, any problems? Okay.
So you are considering half mesh, right? The half part of the circuit,
Yes,
below part,
because
right?
yeah, because I cannot write the mesh pointer. I cannot write KVL for this mesh because there's the current source and we don't know what is the voltage across the current source. Similarly, I cannot apply
Which mesh you can't write KVL, sir?
for this mesh.
Can't see the pointer.
Now, is the pointer visible now?
Mesh number?
It's not visible.
No, sir. Mesh number.
Mesh 1. Like I cannot.
I can see. Oh, mesh.
It is like
Oh,
the mesh
so you
consisting of the.
having the consoles in between two mesh.
1 minute. I cannot apply KVL for the mesh
So
consisting of the 5 ohm resistor, 20 volt voltage source, and the 3 ampere current source. I cannot apply KVL over here.
because the main reason is because the current source is in between two mesh, right?
Yeah. Yes.
Okay. Oh, okay, sir.
Yes. So similarly, I cannot apply over here as well. So that's why I'll apply the KVL across the combined combination of both the meshes.
Uh,
Okay.
so if current source in between, we'll take a combined loop, right?
Yeah, for the combined loop, I'm writing the KVL for the combined loop.
Oh, okay, sir. Okay.
Okay.
Yes, sir.
Yeah. So I can. So this is like this. So I will write it as 20 plus 10 is equal to 30. So 30 minus 20 I2 minus 5 I1 plus 5 I4. This is equal to 0. Okay, I've just expanded this one. Now, if I observe, the 5 is common. Okay, so if I divide this entire equation by 5, I will get 6. 6 minus 4, I will get 6 minus 4I2 minus I1 plus I4, which is equal to 0. Okay. Any problems to this?
No, sir.
Okay.
Simplifying.
Yeah. So now this I1. The I2 minus I1 is equal to 3. So what I can write is as I1 is equal to I2 minus 3. I will just take I1 to this side. I1 I'll take it to the right and 3 I will take it to the left. So that's why I1 is equal to I2 minus 3. So now I will substitute that over here. So I will get 6 minus 4 I2 minus I2 plus 3 plus I4 is equal to 0. So that I will write it down as 9 minus 5 I2 plus I4 is equal to 0.
Sir, the second line 6 minus 4 I2 minus I2 plus I3. Can you once again say that how it's came?
See, I2 minus I1 is equal to 3. Okay.
Yeah, I2 minus. Yes, sir.
So that's why I can write over here. Let me just write over here. So I will take I2 to the right. Okay. So that means I minus I1 is equal to 3
Minus I1.
minus I2. Is this clear?
Yes. So you are saying minus I1 equal to minus 3 times I2.
No. I'm saying minus I1 is equal to 3 minus I2.
Okay. 3 minus I2. Okay. Yes, sir.
So I have minus I1 over here. So I've written instead of minus I1, I've written minus I2 plus 3.
Okay. Yes, sir. Okay. Understood.
Understood, right?
Yeah, yes, sir. Understood.
Okay. Yeah. So we have solved it. So we get 9 minus 5 I2 plus I4 equal to 0. So this is one set of equations. Now we will apply KVL for this mesh. Okay, for this mesh we will apply KVL. So that will be equal to minus of 10 I4. Okay. Then the current is flowing in this direction. That is I4 minus I1. So that will be equal to minus 5 into I4 minus I1 and across this resistor. So the current flowing in this direction, that is I4 minus I3. And we know I3 is equal to 2 ampere. So that will be equal to minus 20 into I4 minus 2 is equal to 0. Okay. So till here any doubt?
Sir, in the recent mesh, which direction is current flowing?
No. We just consider like I am going from here to here. And the current is flowing in this direction, the lower direction. That's why it is minus 10 into I4. Similarly, I am going from here to here, and the current is flowing in this direction.
For 5 volt, then you should take a plus 5 volt, right? Plus 5 into, right?
No. Consider the current is tell.
Because the above sign you have plus and minus, so that's why.
For V2. No. That is not how we do. No. That plus and minus could be opposite also. It will not make a difference.
Okay.
See, the convention just says that if we are going from one terminal of the resistor to the next terminal, as well as the current also is flowing in the same direction, then we give the sign to be negative. That is the convention what the convention states. Okay. So that's why I am going.
If we
Tell.
No, if we consider it from the 20 ohm plus 20 plus 20 into I4 minus 2 amp, whether it will be same?
No, it won't be same. No, because I am writing KVL in the clockwise direction. I am going like this direction. Okay. I am writing KVL in clockwise direction. And when I am going in clockwise direction, the current in which is going like this, that is equal to I4 minus 2. So that's why it will be minus 20 into I4 minus 2.
Okay.
Okay. Any other doubt?
No, sir.
So, now what I will do is, this is like minus 10, minus 5, minus 20. So I will divide throughout by minus 5. So I will get it to be, someone else has joined the meeting. Okay. So I will get it to be, I divide by minus 5. Okay. So I will get it to be 2I4 plus I4 minus I1 plus 4 into I4 minus 2, which is equal to 0. Any doubt in this part?
No, just simplification. Right?
Yeah, this is a simple simplification. So I get it to be
Okay.
minus I1 plus 6I4 minus 8 is equal to 0. Okay.
Yes, sir.
Yeah. So this is another set of equations. So now what we will do is we will substitute. Okay.
The two equations of
No, we
one
made a
equation
mistake.
have I.
No, it's 2 plus 1 plus 4. Where this will be actually 7. Minus I1 plus 7I4 minus 8 is equal to 0. Okay. So now when we will, so what will we have? We have this equation. Okay, what we will do, I will substitute minus, we have this equation. This is one equation. So this is equation 1. Okay, I2 minus I1 is equal to 3. This is equation 1. Similarly, we have equation 2. 9 minus 5I2 plus I4 is equal to 0. Then we also have this I minus I1 plus 7I4 minus 8 is equal to 0. This is the third equation. So any doubts in this? There are three equations.
No.
Okay, so there are three equations and there are three unknowns. I2 is one unknown, I1 is another unknown, and I4 is the third unknown. So in the three equations, there are three equations and there are three sets of unknowns. Okay. So now we'll have to use a calculator to solve this. Okay, so you'll have to go to where it will solve equations which will have three variables. So when we will, what do we do? We will substitute in the calculator. So let us consider equation 1. Yes, tell.
No, in the exam calculator, whether we will have the scientific calculations like solving three unknown variables.
I actually don't have any idea of that actually. I don't know.
In the normal calculator for the exam or the digital calculator, right?
Okay. So suppose that was the scenario.
In our physical,
Near physical?
yeah, yes, sir.
You saying something?
No, in our physical calculator, no, in our physical calculator, we have the facility to solve using three unknown variables.
Yes.
But in this final NPTEL examination, you have only digital calculators.
Oh, cha. Okay. So now what you can
So,
do is, you can substitute the value. Here we have minus I1 is equal to 3 minus I2, right? Minus I1 is equal to 3 minus I2. So I
yes,
will
sir.
substitute over here. Minus I1, I will write it as 3 minus I2. So I will write it down as, right, 3 minus I2 plus 7I4 minus 8 equal to 0. So what I will get is minus I2 plus 7I4 is equal to 5. Okay. There's some TCS virtual calculators available during exam. So let's check that out.
Yes, sir. In TCS virtual calculator,
Ah,
I don't think the finding unknown variable is possible.
okay. So okay, now let us just continue. It may not be possible, so we will consider that scenario. So this is equation 4. Okay, minus I2 plus 7I4
Okay.
is equal to 5. Yeah. So this is equation 2, equation 4. So equation 2, what we can write, I4 is equal to, we take 9 to this side, it become minus 9, and this plus 5 I2, we will take it here. So we can write I4 is equal to 5I2 minus 9. Does this make sense?
It is modified by you modified the second equation, sir.
Yeah. Just modify the second equation.
Ah,
Okay.
okay.
So this modified second equation I substituted in equation 4. Okay. So I will get minus I2 plus 7 into I4. 7 into I4 means 7 into 5, that is 35 I2. 35 I2. Okay. Minus 7 into 9 is 63 is equal to 5. So what I will get is 34 I2 is equal to 68. So I will get I2 to be equal to 2 ampere. Any doubt here?
No.
Okay, so I've got I2 to be 2 ampere. Huh? So I know I2 is minus I1 is equal to 3. That means I1 is equal to I2 minus 3. I2 minus I1 is equal to 3. So I1 is equal to I2 minus 3. I2 minus I1 is equal to 3. So I2 is equal to 2 ampere. So that's why I1 should be equal to actually minus 1 ampere. Any doubt here in this? Because I2 is flowing like this, it is 2 ampere, and I1 is flowing in this direction. But it should actually have been flowing in this direction. So that's why I1 is equal to minus 1 ampere. Okay, so I have got that. Now, what I will do is, I've got I2, I've got I1. Now, in this equation, which is simple, let us consider this equation 4. Okay, equation 4 looks simple. We have minus I2 plus 7I4 is equal to 5. That means minus 2 plus 7I4 is equal to 5. That means 7I4 is equal to 7. That means I4 is equal to 1 ampere. So we have found I1, we have found I2, we have found I4. So the three unknowns we have found by solving the three equations. Any doubts still here till any of the spot?
Sir.
Hmm?
No.
No, right. So we have solved it. So now let us go to the question. Is this visible? The screen is visible, right? Just
Yes, sir.
common data for question 7 to 12. Visible, right? Okay. So the first question they're asking us is I have to find the voltage V1. Okay, I have to find the voltage V1. So if I have to find the voltage V1, then okay, let us see. The voltage V1 I want to find. So that will be equal to there's this V1. Okay. Voltage across V1 is the this resistor into the current across V1. The current across V1 is I3 minus I4. So the current through this resistor is equal to I3 minus I4. So V1 is equal to this 20 into I3 minus I4. Okay, and we know I3 is 2, I4 is 1. So that's why V1 is equal to 20 volt. Okay. Next, we want to find the voltage V2. So the voltage V2 is 5 and we will go in this direction. Okay, we will go in this direction from left to right. So that will be equal to 5 into I1 minus I4. Okay, so V2 5 into I1 minus I4. That is equal to 5 into minus 1 minus 1. So it will be equal to minus 10 volt. Okay. So someone was saying actually, Sutta, you were saying, even though there's a plus or minus, see the actual voltage was opposite in the opposite polarity. This was plus, this is minus. But in the actual effective circuit, this was at a higher potential and this is at a lower potential. Okay.
Yep. Yes, sir.
Yes. So now we have found V1, V2. Next, the question states we want to find electrical power delivered or supplied or generated. That is other forms of power converted into electric power by the 2 ampere current source in watt. So the question is just saying we want to find the power which is either generated or consumed by this 2 ampere current source. Okay. So the formula of power is voltage into current, and this is a simple resistive circuit. So what we need to know is the voltage across the current source. Okay, I want to find the power generated or consumed by this current source that is equal to the current which it is generating into the voltage across this current source. So now if I will observe the voltage across this current source is actually voltage across this V1 voltage plus this 10 volt voltage. Okay, so the voltage from here to here is in actual reality it is V1 plus 10. Okay, so let me go to the next page. So the voltage across the 2 ampere current source is equal to V1 plus 10. All right. I hope it is clear that this voltage across this 2 ampere current source is equal to V1 plus 10. Okay. And we have found V1 to be 20. That's why voltage across the 2 ampere current source is 20 plus 10. That is equal to 30 volt. So the power which is consumed or generated by the 2 ampere current source is equal to the current, that is 2 into voltage across this current source, that is 2 into 30, that is equal to 60 watt. Okay. So
Sir,
yes,
plus 10 how, sir?
why plus?
V2, V1 minus 10. Not
Okay, I'll consider it. Okay, we will see. It is okay. This is clear now?
Clear, sir. Clear.
Yes. So now, it's- let me be. I suppose this is, let us say this is plus minus voltage 2 ampere. Okay. This is plus and this is minus. Huh? So I'll apply KVL to this mesh. Okay, I'll apply KVL for this mesh. Okay. So it will be, I'm going from in the clockwise direction. I'm going in the clockwise direction. So it will be minus to plus. So it will be V2A from plus to minus. So it will be minus of V1 plus to minus. So it will be minus 10 is equal to 0. This is KVL. So V voltage across the 2 ampere current source is actually V1 plus 10. So that is what I've used here. So,
Okay, sir.
okay, so this is the trick. Like this is how you must do it. See, this and the same polarity. So they will add up. That's a way to remember it. Okay. So now we will go to the next question, that is to power delivered or generated by the 3 ampere current source. So for the 3 ampere current source, you'll have to find, okay, so this is the 3 ampere current source. Huh? And we want to find the voltage. We want to find the power delivered by it. So let us consider this to be positive, this to be negative. So this will be voltage across the 3 ampere current source. So V3A. I'm going from here to here. So it will be minus V3A from positive to negative. So it will be minus V2 from negative to positive. So plus 20 is equal to 0. So what I will get is V3A is equal to 20 minus V2. And I have found V2 to be minus 10. So it will come, V3A will come to be 30 volt. So the power consumed or delivered by the 3 ampere current source is equal to 30 into 3. That is equal to 90 watt. Okay. So that's how I found the power delivered by the 3 ampere current source. Next, we will go find the electrical power dissipated or consumed in the 10 ohm resistance. I want to find the power consumed by this 10 ohm resistance. So in this 10 ohm resistance, if you will remember, there's this current I4 which is flowing. So the power consumed by this 10 ohm resistance will be equal to, power consumed by the 10 ohm resistance is equal to I4 square into 10. Okay. So what is the value of I4, which we have got I4 to be 1 ampere. Okay. So 1 square into 10, that is equal to 10 watt. All right. So this is the power consumed by the 10 ohm resistor. Similarly, we want to find the electric power delivered or supplied by the two voltage sources. We want to find the power delivered by the two voltage sources. That is voltage source this one and a voltage source by this. Huh? So that will be equal to, okay. Mhm. So we will consider the current we flowing in this direction, out of the positive terminal of this as well as out of the positive terminal of this voltage source. So the power which is delivered by these voltage sources is for the 10 volt voltage source. Okay, we will consider current coming out of it, that is equal to this current I2 minus this 2 ampere current, that is equal to 10 into I2 minus 2 ampere current plus this 20 volt voltage source into the current coming out of the positive terminal, that is 20 into I1. 20 into I1. So if we find what was I2, we got I2 to be 2 ampere and I1 we got it to be minus 1 ampere. So that is equal to 10 into 2 minus 2 plus 20 into minus 1. That is why we get it to be equal to minus 20. Okay. Yeah. So any doubts here? Any doubt in this part?
Sir,
Yes.
how I2 minus 2 comes, sir?
Ah.
10 into I2 minus 2.
Yes. Okay. Power delivered, like it is generating the power, no? So that means, like, suppose you see if you have a battery and it is delivering power, that means the current will be coming out of the positive terminal of the battery. Okay. So now here I am considering that this battery is delivering power. So that means the current should be coming out of the battery. And that current is actually this is current I2. Okay, and this is the current 2 ampere which is flowing. So the current coming out of the battery is equal to I2 minus 2. That is why it is coming like this. So has this solved it out?
No, sir.
Okay, let me try again. See, if we have, let's say, we have a battery. Okay, in your mobiles, in anything, you have a battery. It is generating some voltage V. Okay, a battery. See, we charge our phone and we discharge our phone. When we charge our phone from our power socket, this is from power socket, current will flow into the battery and it will charge the battery. Okay, so that time the battery is getting charged and it is absorbing power. It is consuming power. Now, when we have removed, like we have removed our battery from, we have removed our mobile from charging, and we are using a mobile for something, okay, or whatever you want to use. So, okay, so this recording should be available. It will be made available, so don't worry about that. Okay. So now, when the where is this? So in case the battery was delivering power, the current will be flowing out of the positive terminal of the battery. Okay. If it was delivering power, and the power which it will deliver will be equal to V into I. And that time the current will be flowing out of the battery's terminals. Okay. So this is the convention for understanding whether it is generating power or it is consuming power. So in the question they told they want to know what is generating power. So from the 10-volt battery source, current flowing out of the positive terminal is in this direction. It's in this direction. And that current is equal to I2 minus 2. Okay. So Gokul, I hope that has helped you. Any doubts? Any further doubts?
No, sir.
Okay. So now this meeting will finish in 2 minutes. Then we'll have to again start another meeting. Okay, so we have done this, we have done mesh analysis, we have completed mesh analysis. So now we will proceed with nodal analysis. Okay. With nodal analysis. Okay. So in nodal analysis, we will first find out the number of nodes n present in the circuit. Okay. What is a node? A node is a junction, okay, where more than one or more than two elements meet. So let us consider this circuit. Okay, there's this node A, there's this node B, there's this node C, and there's this node O. Okay, where more than two or more elements are meeting over here. Like, if you consider this point, it is not a node because there's just one element and the second element. There's no third element. So when more than two elements are joining at a particular point, that is known as a node. Okay. Now we will choose one node as the reference node. So this node has been chosen to be a reference node and is labeled as O. Other nodes are labeled as A, B, and C. Okay. Now the n minus one node voltages, namely. Okay. Okay. Yes. So we in nodal analysis, we are applying KCL and we are trying to find out the voltage at this node B, A with respect to O, voltage at this node B with respect to O, and voltage at this node C with respect to O. So that is our objective. So how do we do that? We use KCL equations are written at each node A, B, C, and the KCL equations will be around n minus 1 KCL equations. And we will observe the circuit and we so have you guys all joined? So I will start. So Gokul, are you able to hear me? You're still connecting to audio. Gokul, you can hear?
Yes, sir.
Okay, so I'll proceed. Huh? So now, okay. So we will consider this circuit, and we will write KCL equations for these, and we will proceed to just have a demo. Okay, we will do it quickly. We don't have much time. Okay, so this is our circuit. Huh? The nodes A, B, C, and this is node O, which is the reference node. And what we will do is we will find the KCL equations. Okay, so let us write the KCL equation at node A. For node A. So the node A is there. There's one current which is flowing like this, another current which is flowing like this, another current which is flowing like this. Okay. So current which is flowing like this is equal to VA upon R1. And O is considered to be the reference node. It is considered to be ground. So it is considered to be at zero potential. So that means KCL at node A will be VA divided by R1 plus VA minus VB divided by R2 plus VA minus E2 upon R6 is equal to 0. Okay, any doubt in this?
No, sir.
Actually, it is wrong. One minute. It's a mistake here. So, till this part it is correct. VA minus VB upon R2. But for here it will be VA minus E2 minus VC. So it will be VA minus E2 minus VC upon R6 is equal to 0. Okay. So it will be this plus this plus this. All right. So now,
Yes, sir.
yeah. So now I will do KCL at node B. All right. That will be now this is my way of solving the circuit. I find it to be easy. I consider that all the currents are going out of the node. One current is going out of the node like this, another current is going out of the node like this, another current is going out of the node like this. So that will be for the current going out of the node in this direction, it will be VB minus VA divided by R2. Okay, VB minus E1. Okay, it will be VB minus E1 divided by R3 plus VB minus VC divided by R4. VB minus VC divided by R4 is equal to 0. Okay, so there is a KCL at node B. Similarly, we can write the KCL at node C. The KCL at node C will be equal to VC. So again, what I do, I consider current to be flowing out of the node like this, and like this. Current flowing out is VC upon R5 in this direction, VC minus VB upon R4 in this direction, and VC minus, and now it comes the fun. VC, and because the potential is in the opposite direction, that is VC plus E2 minus VA upon R6. So it will be VC plus E2 minus VA upon R6 plus VC upon R5 plus VC minus VB upon R4 is equal to 0. Is this clear? Is this point clear? This is a confusing thing.
Clear, sir.
Okay, very great. Very good. Very good. Yeah. So that's why we have written the KCL equations for node A, node B, node C. There are three unknowns, VA, VB, VC are the three unknowns. We consider E1, E2 and the value of the resistors to be known. Okay, these are unknown. Now we will proceed further. All right. So they have used some method and they have found out some things and they have written it. So I'm just giving some demo I have given. Now we will go to solving one previous year assignment question. Okay. So this is a circuit. Let us consider this circuit. Yeah. So this is my circuit. To copy it, I will. Let me start a new page. Yes. Okay, so this is the circuit. All right. So in this circuit, there are 3 points. There are 4 nodes. One node here, two node here, second node here, third node here, and the fourth node is over here. Okay, so this way I will consider to be the reference node over here. So this is my node, and the voltage at this node is V1, the voltage at this node is V2, and the voltage at this node is V3. And these voltages are with respect to this node, which is the ground or reference node. All right. Any doubts till that point? Okay.
No, sir.
So now I will write the KCL at the node 1, which is over here. Okay. So I will write. Sorry. So I will write KCL at node 1. Yeah. So now, as I said, I consider the current to be flowing out. Current flowing out here, current flowing out here, here current is flowing out, and here current is flowing inside. Okay. So as I said, so what I usually do is it will be V1 minus V2 upon 3 plus 7, which is flowing out, plus V1 minus V3 upon 4, and I'm considering the current to be flowing out. Considering current to be flowing out. So that's why it will be minus 4. So it will be minus 4 is equal to 0. Okay. Any doubts in this?
No, sir.
Okay. Yes. Okay, so this is one thing. So what do we further simplify it as V1? Okay, this we will consider to be equation 1. Similarly, I can apply between this node and this node, there's a ideal voltage source. Okay, so the voltage at V3 is equal to, so we have V3 minus V2 is equal to 5. Any doubts in this?
No, sir.
Yeah. Then this is a super node. V2 and V3, these two nodes have a voltage source in between them without any resistance in between them. So there's only a voltage source connecting these two nodes. So these two nodes together form a super node. All right. So we will now write the KCL
Sir,
of, yes.
how V3 minus V2? Sir?
No, see the V3 minus V2 is equal to 5 volt because there's a 5 volt voltage source, right? No,
V2 minus V3 is equal to 5 volt, not chemo, sir. V2 minus V3.
no, it won't be like that. See, this see this 5 volt means this potential at V3 is higher than this potential at V2. It means, oh wait, let me just draw. It means here and here, the potential difference between these 2 points is 5 volt. And this point is 5 volts at 5 volts higher than this point. Okay. So the potential at this point V3 is equal to 5 plus the potential at this point, that is V2. Is this making sense?
Okay, sir.
Yeah, that's the way because uh because it's like a 5 volt difference. So this is at a higher potential and this is at a lower potential. And the difference is 5 volt. So that's why V3 minus V2 is equal to 5. Or we can write V3 is equal to 5 plus V2. Okay. Now we will apply the KCL at this super node. At this super node, we will apply. See, why this super node concept is there is because if we apply KCL at this node V2, the current, we cannot accurately determine it. Because over here, we can do V2 upon 5 is the current flowing out, or that is 7 ampere is the current coming here. But this, we don't know what is the current flowing to the voltage source. That we do not know. So what do we do is, we consider super node, consider V2 and V3, and we apply KCL for this entire super node. Okay. So I'm applying KCL to this entire super node. So at this point V2, what is the current flowing out? Okay. At the point V2, current will be flowing out like this, current flowing out like this, and current will be flowing out like this. And for the node V3, the current will be flowing out like this, and like this, and like this. So when I write the KCL at the super node, I will get V2 minus V1 upon 3. And then I'll get minus 7. This direction, so opposite. So minus 7 coming like this. So V2 upon 5. V2 upon 5. And for this will be V3 minus V1 upon 4. V3 minus V1 upon 4. Plus in this direction, it is V3 upon 2 and minus 2 because it is in opposite direction. So this is my equation 3. Any doubts in this?
Sir, what is super nodes? What is super node?
Yes. Yeah. So super node is the combination of these two nodes. A super node is formed when between one node and another node, there's an ideal voltage source is there. Okay. So we cannot apply KCL at this node individually and KCL at this node individually. So we apply KCL for both the nodes together. Or that means we're applying KCL to this super node.
Okay, sir.
So now I have found this equation. This is the KCL equation of the super node. So it is actually V2 minus V1 upon 3, V2 minus V1 upon 3 minus 7 ampere plus V2 upon 5 plus V3 minus V1 upon 4 plus V3 upon 2 and minus 2 ampere. So this is equal to 0. So this is equation 1, this is equation 3. Now if you observe, okay, if I add so I will add 1 and 3. Okay, if I add 1 and 3, what will happen? This is V1 minus V2 upon 3. This is V2 minus V1 upon 3. So this can be written as minus of V1 minus V2 upon 3. So this and this are actually opposite. So what will happen is this and this will cancel. Minus 7 plus 7 will cancel. This and this will cancel. So when we add, the resultant equation which we will get will be equal to V2 upon 5 plus V3 upon 2 minus 6 is equal to 0. So any doubt till this point?
No, sir.
Okay. So now what we do, we will simplify this. So this we can write it as, what I will do is I will multiply it throughout by 10 so that I get all in the numerator. So 2V2 minus 5V3 is equal to 60. Any doubts in this?
No, sir.
Okay, so I'll proceed. So I'll write, now I will substitute the value of V3. See, V3 is equal to 5 plus V2. So I'll put 2V2 minus 5 into 5 plus V2 is equal to 60. So I get it to be, when I so V2 no, some mistake. 2V2 plus 5V, this plus, so this also plus. So it becomes 7V2 plus 25 is equal to 60. So 7V2 is equal to 35. So I get V2 to be equal to 5 volt. Okay. Any doubts in this simplification?
No, sir.
Yeah. Now I get V2 to be 5 volt. If I put V2 to be 5 over here, I will get V3 is equal to 10 volt. So I found V2 to be 5 volt, V3 equal to 10 volt. Now I will substitute V2 and V3 in this node, in this equation 1. So I will get V1 minus V2, that is 5, V1 minus V2 upon 3, okay, plus 7, plus V1 minus V3, that is minus 10, divide by 4, minus 4, and here I will do minus 4 is equal to 0. Okay, so I will get V1 minus 5 upon 3 plus V1 minus 10 upon 4 is equal to minus 3. Okay, so I will multiply it by 12 so that I will get common thing. So I will get 4V1 minus 20 plus 3V1 minus 30 is equal to minus 3 to 12, that is minus 36. So I get it to be 7V1 equal to 50 minus 36, that is equal to 14. Therefore, V1 is 14 upon 7 is equal to 2. So, any doubt till here?
No, sir.
Okay. Okay, so I get V1 to be equal to 2 volt. Achha? So now what we have to find over here is they told first we must find V1. So we have found V1 to be 2 volts, answer is correct. V2 we have to find, that is 5 volt, answer is correct. V3 we have to find 10 volt, we found it. Now we want to find the current I. So what is the current I? The current I is this current, okay, this current. So this current I will be actually equal to V2 upon 5. So we write this current I is equal to V2 upon 5, that is equal to 5 divided by 5, that is equal to 1 ampere. Okay, so we found the current I as well. Now we want to find the electric power delivered or supplied or generated by the 4 ampere current source, and similarly we have to do it for the 2 ampere current source. Okay. So for the 4 ampere current source, we want to find the power delivered by the 4 ampere current source. So anyone can tell me what is the voltage across the 4 ampere current source? Kukul or who's there? Mohammed, Murshid. What is the voltage
2
across?
volt, sir. 2 volt.
Okay. So as we have found, V1 is 2 volt. So what will be the power then delivered by the 4 ampere current source?
Eight watts, sir.
Yeah. Okay. So that's the way. So it is simple. 2 into 4, that is 8. Okay, 8 watt is delivered by the 4 ampere current source. Similarly, for the 2 ampere current source, what's the voltage V3 we found out to be? If you can
10
remember.
volt.
10 volt. Okay. So power delivered by the 2 ampere source is 2 into 10, that is 20 watt. Okay. So that's what we have done. We have solved. So we have found the answers. 8 watt for this, and for this 20 watt. Yeah. Okay. So these are some of the questions which were there. So let us try this sum. Okay. We will try this sum. This figure 9 we will try. No, let's try this one. Try this one. Okay. So there's this circuit. They have told to use mesh analysis. That's what they have told, that you can use mesh analysis and solve this. But let us try using nodal analysis. Let us try how we can try solving this equation using nodal analysis. We hope we can do it. We do a good job. So let us see. So I have a new page. I'll paste this, and let us go for this. Okay, I'll just say we exercise. So let's start. So what we do, we say there.
Can
So
I
how
say,
many?
sir?
Yes, yes, tell.
Can I say this, sir? Can I say, sir?
See what? See what? You are able to see that?
Method I can say, sir.
Yeah, tell.
So let V be the node, sir. The node V minus 10 divided by 2 plus V divided by 3
Wait, let me write.
minus 2. V
10.
minus 10 divided by 2 plus
Uh,
V by 3
uh,
minus 2 is equal to 0.
yeah. Okay. So one equation we found. So this is the only equation is there. Because this is 0, this is ground node, reference node, and this is node V. So what I will do, I will multiply throughout by 6. Okay. So I'll get 6V minus, no. I will get 3V minus 30 plus 2V minus 12 is equal to 0. So I get 5V equal to 42. So V I get to be 42 upon 5. Okay. So this is the voltage I get. So now this is just some way to calculate everything. What I will do is I want to find it in, like in these questions they say find the answer to the first decimal point, second decimal point, like that. Okay. So it is 42 upon 5. So 42 upon 5 can be written as
8.4, sir. 8.4.
Yes. So that means what we have better way is I just make 84 upon 10. So that is equal to 8.4 as Gopal has said. So the voltage is 8.4. Huh? And now we want to find I1 and I2. So how do we find I1? I1 is be equal to, what is the equation of I1? Can anyone say? Okay. So I1 is the current flowing like this. So I1 is the current flowing to the 2 ohm resistance. So the voltage over here is 10, voltage over here is V. So the current will be 10 minus V1 divided by 2. That is 10 minus 8.4 divided by 2. That is equal to 1.6 divided by 2. So I1 will be equal to 0.8 ampere. Okay. Any doubts in this? Also, we can write.
No, sir.
So also we can say I2 is equal to minus 2 ampere because it's in the opposite direction. So in this question, I personally feel the nodal analysis makes it very simple to solve. Maybe mesh analysis also might be simple in the mesh analysis also will be quite simple. So both this is a simple circuit, so any method works fine. That way. So any doubts till now? Any other questions or queries?
No, sir.
Okay. Now we will consider this circuit. Okay. Let us see this one. Oh, this one. So we'll take a screenshot. Okay. So how many nodes are there in this circuit?
2 nodes.
2 nodes. Okay. A node, B. No, there are 3 nodes. Node A, node B. This is also one more node. This is the reference node. Okay. There are 3 nodes, and this is the reference node, and then we consider for the other 2 nodes. So now we will apply KCL in this. And we'll apply first KCL at node A, and then we'll apply KCL at node B. So we will apply KCL at node A. What we will get it to be? Let us see. It will be what is my method? I consider current to be flowing out, current to be flowing out, current to be flowing out. So it will be VA minus 10 divided by 4 plus VA minus 3 divided by 3. Okay, we have made a mistake over here. This is a super node. Okay, this is a super node. VA and VB are connected by a 5 volt voltage source. So it is a super node. So we have to apply KCL for the super node actually. So we apply KCL for the super node. So now we will consider current flowing out of this as well as current flowing out of this. So it will be VB upon 5 plus VB minus 4 upon 2. This is equal to 0. Okay.
Yes, sir.
Let us simplify it. Okay. Also, what do we know is VA minus VB is equal to 5. Is there any doubt in this?
No, sir.
So what do we do? We put this. VA is equal to VB plus 5. So VA minus
Yes,
10
sir.
divided by 4 plus VA minus 3 divided by plus VB. Okay. So VB is equal to VA minus 5 divided by 5 plus VA minus 9 divided by 2 is equal to 0. Okay. So what do? We multiply it by, let us say this is a bit complicated. Find the proper thing. Multiply it by. Okay, we will just consider. We will first combine this and this. So it will be VA minus 10 plus 2VA minus 18 upon 4 plus VA minus 3 upon 3 is equal to minus of VA minus 5 divided by 5. Okay. So this will be 3VA minus 28 upon 4 plus VA minus 3 divided by 3 equal to minus of VA minus 5 upon 5. So next page. So this will be written as 9VA minus 20 into 3. Just that. 3. 9VA minus 84 plus 4VA minus 12 upon 12 is equal to minus VA plus 5 upon 5. So you multiply. So it will become 13VA minus 96 into 5 is equal to minus 12VA plus 60. Okay. So that will be 65VA. 96 into 5 is minus 480 minus 12VA plus 60. So we take this aside, it will become 77VA is equal to 480 plus 60. That is equal to 540. So VA is equal to 540 divided by 77. This 540 divided by 77. We get it to be around approximately
7.0129.
13. Okay, that's all it's saying. Correct. So, any doubts here?
No, sir.
Okay. So, you guys are from which colleges?
JC Arwal, sir.
From which state?
Bihar.
Okay. In Gokul, you're from South India.
Panimalar, Chennai, sir. Chennai.
Oh, Chennai. I'm from Chennai. Okay. And what is this? Someone else? Audi Lakshmi. Okay. Okay. So now we have solved this. What we have done today, we'll have a recap. We have first we studied mesh analysis, okay, and then we solved. Let us go through it. We've done. Okay, so we first considered one sample circuit, and then we learned how to apply KVL equations for the various meshes. We have various current sources we consider, means various currents in the meshes we consider, and then we apply KVL for each mesh. And what is the convention? What is the polarity of the voltage drop? What is the polarity we must consider for the voltage sources or for the EMFs? We have considered that. And then we have written the equations for the meshes, and then this is the one we have done. Okay. Next, what we have done is we have solved one sum. This sum we have solved, which was there in the previous year assignment. So this is a mesh. There are 4 meshes in this circuit. So we get 4 sets of currents. 4 current variables are there. And one current we directly find out because there's a current source in the external part of the mesh. So directly we can write I3 is equal to 2 ampere. Similarly, for this mesh, like for this case, there's a current source over here. So we directly can write I2 minus I1 is equal to 3. And we don't know the voltage across this current source. That's why we apply the KVL for the lower part of the circuit. So we apply KVL for this lower part of the circuit. So we apply KVL for this lower part of the circuit, we will get one equation. Similarly, we apply KVL for this part of the circuit. For this mesh, we apply KVL and we get another equation. Okay, we cannot apply KVL to this mesh because again we don't know the voltage across the current source. Okay, so now we have this we know this current is 2 ampere. We have one equation for this, another equation over here, and a third equation over here. There are 3 equations, 3 unknowns, and then hence we can find the value of I1, I2, I3. And just because we are in doubt that in case we do not get that calculator, scientific calculator, and we have to find it out more in a better way, we substituted one equation into another equation and we found out effectively we did some simplification and we found out the current I2. Okay, and then we found out the various other currents. Then we found out the voltages, this V1 voltage, this V2 voltage we found out. Similarly, then we found out the power generated by the 2 ampere current source, by the 3 ampere current source. Then we found out the current dissipated by this resistor, the power dissipated by the resistor, that is I square into R, and the current I4 was 1, so it was 10 watt. Similarly, we found out the power generated by these voltage sources, by this voltage source and with this voltage source, we combined them. We found out, so as I said, the convention is when the current is flowing out of the voltage source, that means it is generating power. So that we used that and we found out the power generated. Similarly, then we have come to nodal analysis, where we have considered KCL for a demo circuit. We have found KCL for the various 3 nodes which are there. Like this circuit has mesh has 4. This electrical network has 4 nodes: A, B, C, and O. So what we do, we consider O to be the ground or reference node. So then we apply KCL for the remaining 3 nodes: this node, this node, this node. So we have 3 unknowns: VA, VB, VC, and we consider the resistors and the EMF values to be given to us. Okay, so we get 3 equations and 3 unknowns, and so we can determine the values of VA, VB, VC. Then we solve this example. Okay, so one was so there are this also circuit also has 4 nodes: V1, V2, V3, and this is the 4th node, which is considered to be the reference node. Then we apply KCL at node 1, and as I said, what we usually assume is current is flowing out of each node. So that's why V1 minus V2 upon 3 plus 7 plus V1 minus V3 upon 4 minus 4 amperes. That we from KCL at node 1. Also, this V2 and V3, they form a super node because there's a voltage source connecting both the nodes. Okay, since there's a voltage source connecting these 2 nodes, we find a KCL of the effective super node. So we apply KCL of the super node and we get it to be this equation. Then we add equation 1 and 2, and then we get it into a very simple form. This equation we get into a very simple form. So then we further simplify it and we find the voltage V2, and also we know V3 minus V2 is 5, so we find the voltage V3 to be 10 volt. Then we substitute the value of V2 and V3 in this equation 1, and we get the voltage of V1. Then we find the current through this resistor, that is V2 upon 5. We find the value of current. Okay, so that's how we have solved. And similarly, we also can find the power delivered by this 4 ampere current source and the power delivered by this 2 ampere current source. That also we have found out. So we also considered this demo circuit, small circuit, and we did applied nodal analysis to this, as well as then we applied nodal analysis for this circuit also, and we found the voltage VA. Okay, so any other doubts? Anything else? Hope you guys have understood. So this is what we have done today. So all the best for your. You'll have to submit the assignment this Wednesday. So I hope this session was useful to you, and you guys can have learned something which you will be able to apply in while solving the assignments. Okay. So I will end this meeting. Okay. So thank you for joining.
Thank you, sir.
Yeah. Thank you guys. Okay.
Thank you, sir.
Yeah. Bye.